Okay, guys, today, section 3.5, okay? So, what we have to do for the rest of this section, those 6 parent functions that we learned and the dance moves, we have to keep those because now we're going to start mixing them up. So, like, this dance move of the touchdown is going to turn upside down as well. Move left and right. So, we're talking these 6 parent functions. That's why we spend a lot of time going through those to get those solid so that you have a good footing for what we're about to do. So, remember x squared, this one was the touchdown, okay? So x squared, when we graphed x squared, if we square each of these numbers, remember the graph of x squared looks something like this. Okay. That was our graph of f of x equal x squared. Now, let's look at what would it be like if I graphed x squared plus 1. Okay. Okay. If I graphed x squared plus 1. Okay, so let's plug in these numbers. What is negative 2 squared? Guys, what's negative 2 squared? 4. What's 4 plus 1? 5. What's negative 1 squared? 1. 1 plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared is 4. 4 plus 1 is 5. So now I need to graph these points. Negative 2, 5. So negative 2, 5. Negative 1, 2. 0, 1. 2, 1. And no, 1, 2. And 2, 5. Okay. And if I look at the graph of this in blue, what's the difference between the blue graph and the red graph? How much above? 1. Okay, so what did I do if I started out with the red graph, x squared, what was the effect? What was the effect of graphing that? What happened to the whole graph? It moved up 1. Okay, that's all that happens. So that's just a vertical translation of this graph. It moved up by 1. So anytime you have any graph, so the relationship between f of x and f of x plus 1, it just moves the graph up 1. That's all that happened here. So all of these 6 functions that we just graphed, I can ask you to graph f of x plus k, okay, where k is just some number. If it's a positive number, it's moving the graph where? Up. If it's a negative number, it's moving the graph down, okay? So that is a translation that we can now graph each of these functions. So let's look at, what graph is this one? This is what? The v absolute value, okay? So this is the graph of the absolute value of x. What I want to do now, let's just graph f of x minus 3. So it means do what? What does it mean if I'm going to graph f of x? This is the graph of f of x. How do I graph f of x minus 3? What would I do? Right, so every value goes where? Down 3, okay? So I don't really have to pick points. I can just look at this and say, this is at 0. Where is it going to be after I move it down 3? It's going to be here, okay? This point right here, 1, 2, 3, is going here. This point, 1, 2, 3, is going here, okay? So what I see is this. So this is my new graph, okay? Now let's answer questions about this. Where is the vertex in this new graph? Which of these points is the vertex? Yeah, 0, negative 3. The domain and range. A lot of you are going to have to spend some more time looking at domain and range. You got to figure out how to do this. There were a lot of little points that were sort of left on the table. The domain is a set of all x values. So I start over here. Are there x values on that blue graph? Yes, this keeps going forever. So the domain is what? Yeah, negative infinity to infinity. Now there are some people that miss the range points, and I'm not sure how else to explain this. Range is the y value. Are there any y values down here? What, right here there are not. So as I travel up, I am not seeing y values until I get to where? Negative 3. So the range starts at negative 3. It includes negative 3, okay? And then the range keeps going for how long? Yeah, it keeps going up to infinity, Okay, so the range is from -3 to infinity. Where is this function increasing or decreasing? To figure out increasing, decreasing, you travel from where to where? Left to right. As I start traveling from left to right, as I go along this axis, is the graph of that function going up or going down? It's going down. So it starts decreasing, and it decreases from where to where? -infinity to, I'm traveling on which axis? The x. It decreases from -infinity to 0. Okay? Increasing and decreasing is always parentheses. Okay? So it's decreasing from -infinity to 0, and then what does it do from 0 to infinity? It increases from 0 to infinity. Okay? The new function that we just graphed, that blue one, is it even or odd, or neither? It is even. You can see that blue graph is symmetrical about the y-axis. Okay. Right. I'm just asking. And this one, I didn't make it clear, but that's what I was asking. I meant for you to do is about the new graph that you drew. I could ask those about the original, but everything we're shifting gears in now is about the transformation. So transforming these functions. Okay. So let me just take a pause real quick. You guys work on this one. While you are working, I'm going to graph the original. So you should see something that's starting to look like the one that I just have here. So if you need, while you're starting out, if you need to draw the original, that's fine. You can draw the original and then just move everything up 4. I needed you to memorize the original graph so you can draw a very accurate square root of x. So what you don't have time for is, oh, let's plug in numbers here and square root of this and add 4. You know, that just takes too much time. So if you know how to graph the square root of x, and we spend a lot of time on that, if you know how to graph the square root of x, the square root of x plus 4 in this form just moves the graph up 4. Okay, so it's just a transformation. So what is the domain of the red graph? Of the red graph, yeah, the red one. Yeah, it's 0 to infinity. What goes around the 0? A bracket. What is the range of that red graph? Yeah, it's 4 to infinity, okay? There are no y values on that red graph until I get up to 4, okay? And then this function, where is it decreasing? Never. It's increasing from where to where? 0 to infinity, okay? So those are the questions. And then I think if you'll turn the page, I think there's another graph I want you to do. So work on the next one. X to the 1/3 plus 4. Draw the original, that is fine. It just needs to be clear to me on a piece of paper. You know, if you're using 2 colors, you could say the blue is my answer or something like that. Or you could then erase the original. Just if you're going to do this on a test, I need to know exactly which one is clear. So you get to do enough of these and you can do it without drawing the original. So if I look at this, what's the domain of this one in blue? What is that domain? -infinity to infinity. What's its range? The range of the blue one. These arrows means it's going to keep going on and on. So it's going to keep going to the right and up. This is going to keep going to the left and down. So the range is what? -infinity to infinity. It keeps on going. Now the blue, let's look at the gray one. The gray function, is it even, odd, or neither? Odd. What about the blue one? I'm hearing several things. Is it odd? Or you're saying even? Okay, what is an odd function? Odd function means it's symmetric about the, no, even is symmetric about the y-axis. Odd is symmetric about the origin, okay? So it means relative to the origin, it's symmetric. So here, this one goes up, this one goes down. Is that symmetric about the origin? No. Okay. So this the blue function is, so this one is odd, and this blue one is neither. Okay. Because if you look at what's it doing relative to the origin, it's not symmetrical about the origin. Okay. So you can move that odd function, and it's no longer an odd function. Yes. It doesn't what? Right, it's even functions are symmetric about the y-axis. So the one that we did a moment ago, when we were looking at the absolute value, this guy right here, this red function, is that even, odd, or neither? The red one. Even. What about the blue one? It's even. Okay, so an even function, I can move up or down all day long. It's symmetric about the y-axis. So what happens is on even functions, this is a mirror image of this. This is a mirror image of this. Okay? But with odd functions, when you move an odd function up or down, you lose that property. Okay, so this is symmetric about the origin. If I move it away from the origin, it's no longer symmetric about the origin. Okay, so just another property there. So that's part one of what we're doing today. Part two is taking these functions and reflecting them. Okay, you're in luck because this is just in time for the weekend. So you only had 6 dance moves last weekend. What is this one? Which is what? X squared. Absolute value of x. This one was, what did we call this one? Egyptian. Okay, yeah, that's x cubed. What is this one? X to the 1/3. This one, x to the 2/3. X squared. Okay, so now what we're doing to double those dance moves is you can have this is x squared, this is negative x squared. Okay, and then if this is the absolute value of x, this is negative absolute value of x. So everything is reflected about the x-axis. So this first one here, that's negative x squared. What do you think this one is, the second one? Negative square root of x. This one is what? Negative absolute value. Then what about this one? So this one sometimes people have trouble seeing. This is x cubed. If I reflect it about the x-axis, it turns into this, okay? Which is what you see here. So this is negative x cubed. What about the next one? Yeah, negative x to the 1/3. So this is x to the 1/3. It goes up here and down here. Reflecting it would mean it goes down here and up here, okay? Which is what you see here. This is negative x to the 1/3, or negative cube root of x. Those mean the same thing. And then what is this last one? Yeah, negative x to the 2/3. So it's the seagull is just turned upside down. Okay. So now we can move functions up and down, and we can reflect them about the x-axis. So let's see how that helps us in graphing. Okay, so let's look at this. I want to graph negative absolute value of x minus 2. What does that negative in front tell you that has happened? It's been reflected about the x-axis. So the answer to this first question is yes. It's been reflected about the x-axis. And then has it moved vertically? What did it do? Goes down 2, okay? So you know what the absolute value of x looks like. You know that the absolute value of x looks like this. Now what we need to do, we need to graph a function that reflects it about the x-axis and moves it where? Down 2. So instead of starting here, where am I going to start? Right here, okay? And then instead of the graph doing this, what's it going to do? It's going to open down. So this is all I really need to do is it's this, okay? That's my graph, okay? So it's the absolute value of x that has been reflected about the x-axis, turned upside down, and then moved down 2, okay? What's the vertex of this guy? Yeah, 0, negative 2. What is the domain? Yeah, negative infinity to infinity. What's the range? Negative infinity up to where? -2. So on the y-axis, I start at negative infinity and I stop getting values at -2. Where is this thing increasing? Yeah, as I travel from left to right, it increases from negative infinity to, no. Travel from left to right. Negative infinity to 0. I'm on the x-axis. So negative infinity to 0, and then it decreases from 0 to infinity. Okay. So I can just ask those same questions we've been asking. Is this even, odd, or neither? It's even. Does it look like a mirror image if the y-axis was a mirror? Yes, it is symmetrical about the y-axis. Okay. So let's look at the next one now. So, pardon me? Yeah. Okay. So this is why it's key that you know all 6 of those graphs, okay? This one is going to be based on which graph that we know? Come on, guys. Yeah, x cubed. This is going to be based on x cubed. So if you need to do this, okay, that's what x cubed looks like, okay? And now I'm doing something to x cubed, okay? What does that negative in front tell me? Yeah, it's going to be reflected about the x-axis. So reflected or flipped about the x-axis. Am I moving this thing vertically? Where? Up 5, okay? So I just need to graph x cubed that's going to be reflected and moved up 5. So this point right here is the origin. That's always a good point to start with. What happens if the origin gets reflected? Does it move? No, it does not move. So that's a good point. So this point right here, if you reflect it, it doesn't move. Where do I need to move this point now? Up 5. So I go up 5. This is my new origin of my graph, okay? But instead of it looking like this, it's going to look like, what happens when you flip this? It's going to look like this, right? That's what happens when this thing gets turned upside down. Does everyone see that? Okay. So instead of graphing x cubed from here, I'm going to be doing something that looks like this. So that is the graph of negative x cubed plus 5. So what is the vertex, or this one doesn't have, it has an inflection point really, but this inflection point, what is the inflection point on this? Yeah, 0, 5, domain. Yeah, these things all have the same domain and range. Where's this thing increasing? Okay, increasing, guys. Travel left to right, okay? As I travel from left to right, all along this axis, is the graph of that thing going up or down? It's going down. So it is decreasing from negative infinity to infinity. It always decreases. That means where is it increasing? Yeah, nowhere. The range is the set of all y values. Okay, so I come down to the bottom of the y-axis. Okay, this graph is going to keep going down forever. So I get y values from negative infinity up to positive infinity. Okay, so x cubed and x to the 1/3, its domain and range are all negative infinity, infinity. So again, this is why we spend a lot of time graphing these guys. Is this one even or odd or neither? It's neither. The original function was odd. Okay, the original function in blue was odd, but this one, when you move it up, it's not symmetrical. It's not symmetrical about the origin. So this is neither even nor odd. Okay. Okay, you guys take a look at the next one. So I'm going to pause that real quick, and then we'll go. Or you can just draw it off to the side. Sometimes I'll just say, okay, this is my starting point. That's what x to the 2/3 looks like. Okay, so I don't want to miss that. Okay, and has it been reflected? Yes. And then it moves up 5. So its vertex is 0, 5. Its domain, what's the range of this guy? -infinity to 5. Where does it increase? Nope. -infinity to what? 0. So as I travel from left to right, it's going up from -infinity to 0, and then it decreases from 0 to infinity. What? Okay, increases is measured on the x-axis. So I'm starting over here. My function increases until I get to where? This is 0. That's not on the x-axis. It's the x-axis. So I'm increasing as I travel on the x-axis from -infinity to 0. And then I decrease from 0 to infinity. There's only one time you go to the y-axis. So which one is that? The range. So the range of this function is from -infinity up to 5. So -infinity to 5 is the range. The only time you ever look at the y-axis is when I ask you for the range. Now what is this function even, odd, or neither? Yeah, this is an even function. Okay, so we knew that x to the 2/3 was even. You can move it up and down all day long and it stays even. Okay. Which one? The one before this? Okay. So odd function means it is symmetrical about the origin. So whatever it does on one side of the origin is doing exactly the opposite. Okay. So if I gave you, let's just look at the left part of this. So let's just say, for example, let me just take that off. So we said that this function looks something like this. Something like this. If this were an odd function, I would need to see something that looks like this. That's what would make it odd. Okay, I don't see that because what I saw here was something that looked like this. Okay, that was the graph that I saw. To make it odd for this, I would have to have something down here that points the other way. So odd means it is symmetrical about the origin, and that's not the case here. So what it's doing on this side of the origin is not exactly opposite what it's doing here. Now, when it was right here in the middle, where this red line is odd, what it's doing up here is doing the opposite down here. So when you move an odd function up or down, it's no longer odd. Move an even function, it stays even. I think we are near the end, and yes, that is it. Okay. So what you need to be able to do at the end of this lesson is all 6 parent functions, be able to graph them upside down, and then be able to graph them as they move up and down. Okay. So the clue that it's upside down, what's your clue that it's upside down? A negative in front of it. And then what's your clue that it moves upside down? It moves up or down. There's a number tacked onto the end of the equation. If it's positive, it moved where? Up. Negative, it moved down. Okay? That is it. Okay? So